The Big Bang theory is the most widely accepted scientific explanation for the origin of the universe. It does not describe the explosion of the space but rather and the expansion of the space itself. According to this theory, the universe began as the extremely hot dense point around 13.8 billion years ago and has been expanding ever since. This idea has transformed our understanding of the time, space, matter and the energy. You are watching the Universal Knowledge Group channel. In today's videos, we have to know about the theory of the Big Bang. Let's start the video. One of the most common questions is what existed before the Big Bang? The honest scientific answer is we don't know. The time itself began with the Big Bang, so we asking what happened before it may not even make a sense in the physical term. The current physics break down at the point because the law we understand today we cannot describe the condition of the infinite temperature and the density. At the very beginning, the universe existed the singularity and the state where all matter, energy, space and the time were compressed into the unimaginably small point. The temperature was the billion of times hotter than the core of the sun and the density was so extreme that we know the physics cannot fully explain it. With a tiny friction of a second after the Big Bang, the universe experienced the phase called the cosmic inflation. During this moment, the space expanded faster than the speed of light. It does not violate relatively because it was the space itself expanding, not an object moving through the space. Why the universe appears flat? Why the distinct region looks similar? Why the tiny quantum fluctuation grew into the galaxies? As the universe expanded into being too cool, the energy transformed into the matter through the Einstein equation E is equal to mc square. This process creates the fundamental particle like the quark, electron and the neutrinos. The quark combine to form the proton and neutron which later become the building blocks of an atom. About 380,000 years after the Big Bang, the temperature dropped enough to the electron to combine with the proton and form a neutral hydrogen atom. This movement is called recombination. Once the atom formed, light was finally able to travel freely through the space. This ancient light is still visible today at the cosmic microwave background radiation CMB. The CMB is one of the strongest piece of evidence for the Big Bang. It is a faint radiation detected in every direction of the universe and represents the afterglow of the early cosmos. Which discovered in 1965, the CMB shows the universe was once hot and dense. The tiny temperature variants that lead to the galaxy formations. Strong support of the Big Bang prediction. Over millions of years, the gravity pulled the hydrogen and helium gas into the dense region. This region collapsed to form the first star. Inside a star, the nuclear fusion created heavier elements like carbon, oxygen and iron. Galaxies form a massive collection of the star gas and the dark matter. Our own Milky Way galaxy formed around 13.6 billion years ago. One of the most important facts supporting the Big Bang is that the universe is still expanding today. In 1929, the astronomer Edwin Hubble discovered that the distant galaxies are moving away from us. The further they are, the faster they recede. This observation led to the Hubble law, which proves the space itself is stretching. The Big Bang theory also involves the mysterious components, the dark matter, invisible matter that hold the galaxies together, the dark energy, the force causing the expansion of the universe to accelerate. Dark energy make up about 68% of the universe while the dark matter account for the 28%. The ordinary matter, everything we can see, make up to only 5%. In the science theory are not guesses, they are the explanations supported by the evidence. The Big Bang theory is supported by the expansion of the universe, the cosmic microwave background, abundance of the light elements, the large scale structure of the galaxies. While the details are still being refined, the Big Bang remains the strongest model we have. The common misconception. The Big Bang was not an explosion at the single point in space. It did not create the universe from a nothing in a simple way. It does not explain the everything. Quantum gravity remains unknown. Instead, it describes how did the universe evolve to form an earlier hot state. Scientific proposes the several possible endings. The Big Freeze. The universe expands forever and cools. The Big Rip. Expansion tears everything apart. A Big Crunch. Expansion reverses into collapse. The current evidence suggests the Big Freeze is the most likely outcome. The Big Bang theory connects everything from a galaxy to atom to the human existence. The elements in our body were formed in a star that we are born because of the Big Bang. In the real sense, we are made up of stardust. The Big Bang theory is not just about the past, it helps us to understand the present and predict the future of the universe.